We've finished discussing data preprocessing, so let's quickly review some important points and common mistakes to avoid. First, it's crucial to avoid target leakage as much as possible. If the model knows what we're aiming for during training, it can easily become biased by overemphasizing certain data points. For example, when using target encoding, we might replace a categorical value with the average of the expected output. However, when there's enough data, that average already reflects the expected overall trend. If we then let the model try to learn that pattern again, it may end up overfitting to this information. As a result, when the model encounters new data where that cheating knowledge isn't provided, it might perform very poorly. The second issue is to be careful not to overclean your dataset. Sure, we want an organized dataset, and if you find a problematic data sample, the simplest solution might be to just delete it. However, as an engineer, every data point is valuable. Deleting data should be your last resort. For example, in this case, we have only 4 data points, but 3 of them have issues too, with missing values marked in red and 1 outlier, where 6 customers only ordered 1 Coke, which clearly doesn't make sense. The simplest fix might seem to be just removing those 3 data points. However, if we do that, the dataset would be left with only 1 data point, which is obviously not acceptable. This is what we call overcleaning. As engineers, we should value every data point. So when we encounter problematic data, we should try to fix it first, and only consider deleting it if it can't be salvaged. Another common issue is biased imputation. Simple mean imputation can distort the data distribution. Plus, our own subjectivity sometimes leads to improper imputation. For example, if we already know what the target should be, we might introduce bias during imputation, which can eventually result in target leakage. That's why advanced imputation methods like K&N might be necessary in some cases. However, even with advanced imputation, there's still a risk of bias, so it's important to double-check that the operations you're performing are reasonable. Finally, when you get a new dataset, always remember to check if data normalization is needed. Typically, if you're using a well-organized dataset, it might already be normalized. But if you're working with data you collected yourself, it's likely to be skewed, so performing normalization yourself is crucial. The best practice is to print out a few data points at the beginning and manually check for any skewed values. Remember, a well-processed dataset can speed up the entire machine learning task. Often, high-quality data is more important than having fancy algorithms. Finally, let's wrap up this topic with a quick summary. We've spent a lot of time here because a carefully preprocessed dataset can make a huge difference in machine learning tasks. Machine learning projects can often be tricky, and like traditional algorithm-based problem solving, it's not always easy to pinpoint the source of an error. For example, sometimes the algorithm and the dataset might be fine, but if the parameters are off, even a small tweak can lead to a much better result. On the other hand, if there is too much noise in the data, it can mislead the model during training, and no amount of parameter tuning will fix that. That's why it's essential to ensure that your dataset is as clean as possible before you dive into a machine learning project. In this topic, we talked about the definition and importance of data preprocessing. These questions don't have fixed answers. If you understand the logic behind data preprocessing, you should be able to come up with a rational explanation. We focused on common preprocessing methods like K&N for data cleaning, one-hot encoding for data transformation, and data normalization. For your homework, you'll need to preprocess a dataset. Start by analyzing the problems in the dataset, then propose logical solutions, and finally write code to demonstrate your preprocessing steps. Remember, not only for the homework but for all your future machine learning tasks, always keep in mind the common pitfalls and considerations in data preprocessing, such as avoiding data leakage and making sure you perform proper data normalization.